Okay, question number 19, May, June 2016, paper 2, variant 2, question about exponential increase. Okay, so it's very much linked to compound percentages or compound interest. We're told that it is estimated that the world's population is growing at a rate of 1.14% per year. On January the 1st, 2014, the population was 7.23 billion. Find the expected population on January the 1st, 2020. So from January the 1st, 2014 to January the 1st, 2020, you've got 6 years altogether. Okay, so it's going to increase. So this is an exponential increase. So it's going to be itself plus 1.14% more. Okay, 1.14% of itself added onto itself, okay, at the end of the first year. So you're going to get 7.23 multiplied by, you've got 100% plus 1.14%, which gives you 101.14%. Now if I write that as a decimal, it's going to be 1.0114. 1.0114, okay, and this, if you multiply by 7.23, will give you the population after 1 year. So that will be the population on the 1st of January 2015. We want the population on the 1st of January 2020, which is 6 years. So I have to keep multiplying. Now I'm going to multiply this again by 1.0114. It will give you for the next year, and then again for the next year, then again for the next. So altogether, you're going to have to do it 6 times. You're going to if you just put to the power of 6, that solves the problem. And that's from the compound percentage, compound exponential increase formula. You've got the new value is equal to the original value. You've got 1 plus r over 100 to the power of n. This is a formula that formalizes that idea, where you have the original amount, and then you've got 1 plus the increase. If it's an increase, you put plus. If it's a decrease, you put minus. That's for exponential decrease, like decay or half-life, things like that, where something is reduced or depreciates in value, for example. So you have 1 minus for that. This is 1 plus because it's an increase, it's growing. Okay, the rate, right at 1.14 divided by 100. Okay, so that gives you 1 plus r of 100, gives you this 1.0114. This is using the formula here. This is just using your head. So I personally prefer to not have to memorize things. So that's going to give us the expected population on January the 1st, 2020. So you take your calculator out and you make sure you put this in properly. So you've got 7.23 times, and then you got 1 point, be very careful here, 1.014. 1.014, just make sure I've got that correct. 1.014. See, it's 1.0114. Got to be very careful when you're using your calculator with this 114. Okay, 1.0114. And I've got to raise that to the power of 6. So I look for the one that says x with a power which is blank, x to the power of blank. Okay, so that means I'm going to write here the power of 6. Let's put equals, and it gives me my answer, which is 7.738 7.7388 ... So we want to write our answer to 3SF. Don't say anything else here, yes. Don't say anything, you've got to do 3SF. 7.74 billion is the population expected to be on January the 1st, 2020. Now part B, find the year when the population is expected to reach 10 billion. Okay, so in which year will the population reach 10 billion? Okay, so this is a question which is relatively new in the syllabus. There are very few questions like this, and it's an important one because it could definitely come up, and you won't see this pre or prior to 2015. You won't see this at all. Okay, it is estimated, so basically we know that the increase is 1.14, so we know that this is the multiplying factor. So we can continue on, we know that 7.23 times 1.0114 to the power of n, the number of years, we have to find that. And we want to know when this first gets to 10 million or gets greater than 10 million. Okay, we want to find the year in which this exceeds or reaches or gets bigger than 10 million. 10 billion, sorry. Okay, this is 7.23 billion. Okay, so what we can do is we can use trial and error. Now I know that when I put n equals 6, I'm going to get 7.74 billion. So it's got to be more than 6. Let's try, for example, 10. Let's try 10. Okay, when we try 10, we put n equals 10 into this formula. What happens is we get the following. We get the following. You're just going to go back here and change that 6. I'm going to change it for 10. Let's see what we get. Okay, we get 8.09. Okay, that's too low. Okay, that's too low. 8.09. It's too low. Alright, so let's try, for example, n equals 20. If it gets too high, we can go back. I'm just going up by 10s and see what happens. Okay, so let's see. It didn't go up that much, you see, between 6 and 10, did it? Okay, so let's try 20. So go back, sorry, and change that 10 for 20. That gives me 9.07, 9.07, which again is too low. It's getting better. That's too low again. Oops, something happened to the calculator. Let me fix that. Got to set up again now, don't I? Let's put that on. No problem. So you got 7.23. 7.23 times 1.0114 to the power of, okay, to the power of, we've tried 20, that was too low. Let's try 30. That's a big jump, but look, between 10 and 20, it's just gone up by about 1. So let's see, it might be just right. Let's have a look and see. When I put 30 now inside that power, all right, they're getting somewhere. It's 10.15 or 10.16, 10.16. So now let's just make sure, because it could be that's a bit too high. Let's see if it's correct. If we put n equals 29. That should tell us whether we're on the right tracks here. 29. So if I change it to 29, if it's still over 10, we can go to 28 and see. If we pinpoint when it starts increasing first. Okay, it's still above 10, so it's still slightly too high. I'm guessing when n equals 28, we're going to get something just slightly too low, and then that will mean we've pinpointed what we need to pinpoint. So I'll change that to 28. And if that is below 10 million, yes it is, it's 9.93. Okay, that was 10.0 something. So this is 9.93, okay, which is too low. So we can see that it is during the 28th year. In the 28th year, okay, it's going to reach 10 million. So somewhere in the 28th year, during the 28th year, okay, after the 28th year starts and before it ends, in that year, it will reach 10 million, okay? So 28 years after 2020, that's going to be 2048. We've got 2020. Oh, sorry, what am I talking about? We didn't start at 2020. It started at 2014, so you've got to read very carefully. This was a population in 2014. So what I mean is, after 2014, if you add 28 years to that, you're going to get, it's going to give you 42. 2000, and in the year 2042, it will first reach 10 million. Okay? That's what they're asking. They find the year when the population is expected. It's during that year it's going to reach 10 million. It's not asking you, like at the end of which year will it have reached 10 billion. It's telling you that basically in which year will it reach 10 billion? During which year? Okay, which is 2042. Okay, and there we have our answer.